Hi, I'm Prof. Johnny. Welcome to Goodwill Training and Assessment Center Incorporated. May kasabihan tayo, na sa Diyos ang awa, nasa tao ang gawa. So ano pa hinihintay natin? Tara na at gawa na tayo! Here I am again to perform the last method of taper turning, which is the Tailstock Offset Method. The Tailstock Offset Method should only be used when the lathe machine is not equipped with taper attachment. The tailstock center must be out of line with the head stock center, enough to produce the required taper. However, the amount that the tailstock may be offset is limited, and the workpiece is mounted between centers. The tailstock may be offset by three methods, namely, by using a filler gauge. Second, by using the graduation on the end of the tailstock, or known as a visual method. And third, by using a dial indicator. And I will use the last two methods, the visual method and dial indicator, at the same time in offsetting the tailstock so that we can produce a more accurate taper. So let's focus on the step-by-step procedure in cutting a taper using the tailstock offset method. First step, calculate the amount the tailstock must be offset to cut the desired taper on the work. This time, I will cut a metric taper which has a ratio of 1:20 taper by 100 millimeters taper length on a workpiece 400 millimeter long. The small diameter of the tapered section is 30 millimeters. Let's calculate first the large diameter using this formula. Large diameter is equal to small diameter plus the amount of taper per millimeter of unit length. So, the large diameter is equal to 35 millimeters. And the tailstock offset can be calculated as follows. Tailstock offset is equal to large diameter minus small diameter divided by 2 times the length of taper multiplied by the total length of the work. So, the tailstock offset is equal to 10 millimeters. Step number 2, adjust the tailstock spindle to the distance it will be used in machining setup and lock the tailstock spindle clamp. Okay, I will now adjust the spindle of the tailstock and lock it. Okay. The next step, mount the dial indicator in the tool post with the plunger in a horizontal position and on center. So, here is the dial indicator. Horizontal na siya. The next step, using the crossfeed handle, move the indicator so that it registers approximately 0.5 millimeter on the work and set the indicator and graduated color to 0. So, I will now set the dial indicator up to 0.5 millimeter. The plunger is contacted already with the spindle of the tailstock. Ayan, so iset natin sa 0. Ayan. Tsaka a graduated color of the machine should also be set to 0. Then lock. Ayan. Then next step, loosen the tailstock adjusting screw and tighten the opposite one until the tailstock offset is shown on both the dial indicator and on the graduated scale at the end of the tailstock. Okay, take note. The tailstock may be offset toward or away from the operator. When the offset is toward the operator, The small diameter of the workpiece is at the tailstock, with the diameter increasing towards the headstock. And this is what I will do now. I will now loosen the two lock screws of the tailstock. Here is the other one, and on the other side. Okay. I will loosen on this side so that the tailstock will move toward the operator. And this side, I will tighten it. Okay. Take a look on the graduated plate on the tailstock as well as the dial indicator. Okay, the long pointer is moving clockwise. That means the tailstock offset is toward the operator. Okay, 1 mm, 2 mm, 3 mm, 4 mm, 5 mm, 6 mm, 7 mm, 8 mm, 9 mm, okay, almost approaching 10 mm, few graduations more, then ayan na 10 mm, the pointer should be at exactly at the 0 line. Okay, so the tailstock already offset with 10 mm towards the operator. Take a look also on the graduated plate. Next step, tighten the tailstock screw that was loosened. So ito yung lock screw that was loosened. I will now tighten it, being sure that the indicator reading does not change. Step number 7, tighten the tailstock clamp nut. Okay. The tailstock axis already adjusted 10 mm from the headstock center toward the operator. Next step, mount the work between centers. This is how to mount the workpiece between centers. We will use a dead center on the headstock spindle, a live center on the tailstock, and a bent tail lathe dog, and a drive plate. But since I don't have a drive plate, a face plate can also be used. And I will now tighten the lathe dog into the workpiece. Okay, the workpiece is now mounted between centers. We used a drive plate which drives the bent tail lathe dog, and the bent tail lathe dog also drives the workpiece, and the two lathe centers will maintain the alignment of the workpiece while turning operation is going on. Next step, set up the cutting tool as for parallel turning. Note the cutting tool must be on center. Again, I always give emphasis on the importance of setting the tool bit on the center of the job, because this will not just produce quality workpiece, but also safety of the operator. Now, to know more about it, please watch my tutorial video about setting the tool bit in the lathe machine. Next step, starting at the small diameter, Take successive cuts until the taper is 1 to 1.5 millimeters oversized. Another reminder, always start to cut the workpiece with a light ring cut around its circumference or periphery to set the nose of the tool bit with the outside surface of the workpiece, and a light trial cut to produce the true diameter before setting the depth of cut for roughing cut. But in this method, I have to apply 2 or more roughing cuts to avoid too much cutting pressure because the work is mounted between centers is not as rigid as the work mounted for other turning operations. I will now start by producing a light ring cut around the periphery of the workpiece to set the tool bit on the outside surface of the workpiece. Then I will feed a light cut at least 1.5 millimeters length. Then measure it. Okay, 35 mm. So 35 mm minus the small diameter of the taper is 30 mm. So there are 5 mm difference, which is the material removal. So I will apply at least 2 roughing cuts with a depth of cut of 1 millimeter per cut, and I will leave 0.5 millimeters for finishing cut. Okay, I will now rough turn. For the first roughing cut, I can use an automatic feed in this method. Take a look on the workpiece and the cutting tool. Though the center line of the workpiece is no longer parallel with the bed of the machine, the tool bit continues its movement parallel with the bedways of the lathe machine, resulting in a tapered workpiece. Okay, that is the first roughing cut. Again, I will feed 1 millimeter for the second roughing cut. Tingnan nyo ulit yung workpiece and the cutting tool. Kahit wala na sa alignment yung center line ng workpiece, the cutting tool travels a line parallel with the bed of the machine to produce the taper. Okay, roughing cut already finished. Now to be sure, I have to check the measurement of the workpiece for the finishing cut. Okay, 31. So I still have 1 millimeter, which is for finishing cut. So I will now feed a depth of cut of 0.5 millimeter. And a lower feed rate and a higher RPM. So here's now the finishing cut. Okay. We'll now check the workpiece, and another way to check the uniformity of the taper is to lay a straight edge along the length of the taper and look for any deviation of the angle or surface. Okay? So let's check it. I will lay down this straight edge along the length of the taper. If there is any deviation or gap between the straight edge and the surface of the workpiece, so voila, perfect. There's no deviation. Okay, in case there is a deviation or gap on any part along the taper, it is the cause of backlash or the tool bit which is offset on the center line of the workpiece. Another way to check the accuracy of a metric taper is by applying a layout die to the taper section of the work. Then lay out 2 or more lines which have the same distance apart, which is 20 millimeters, since the taper section is 1:20. Then I will now measure the diameters carefully with a metric micrometer at every line. The difference between subsequent diameters should be 1 millimeter for each unit of length. I will start to measure from the small diameter toward the large diameter. Okay. 30 millimeters. Next line. 31 millimeters. Next. .32 millimeters. Next. .33 millimeters. Next. .34 millimeters. And for the large diameter, 35 millimeters. Perfect. And for the taper length, 100 millimeters. Very good. So no adjustment to the taper setup is needed. Okay, so let's have Q&A portion. Prof. Johnny, why do we need to mount the workpiece between centers? Let's take a look on the workpiece held in the chuck. It cannot be moved either side. Thus, the tailstock also prevented from offsetting in order to turn a taper. Unlike in the workpiece between centers, the workpiece can be moved freely into any direction. Thus, the tailstock also free from offsetting to turn a taper. Okay? Another, Prof. Johnny? What is the advantage and disadvantage of tailstock offset method? Using this method, the length of taper is from the headstock to tailstock center, which allows for longer tapers than can be machined using the compound rest and taper attachment methods. Okay? But Since the workpiece is mounted between centers, this method of taper turning can only be used for external tapers. Okay? And in this method, the stiff taper or standard tapers on the end of a long workpiece cannot be machined. Ito yung malalaking angle or stiff tapers. The arbor of the milling machine. Another Prof. Johnny, sapat na ba ang lathe machine finish sa tapered workpiece para gamitin as tool? It depends on the uses a workpiece is intended to. Many of the tapers like the lathe centers, drill chuck, and machine spindles are grind finish to produce high degree of accuracy and surface quality. But before grinding process is done, the workpiece must first be hardened. Kung ang ginawa ko ngayon ay kailangan i-grind finish, then it must be oversized about 0.3 to 0.5 millimeter for grinding process. So, expect more tutorial videos about machining processes, including grinding operations.